All right, chemistry class, let's talk about orbitals and the rules for filling them. So, if we can move on. So, there are two different things that I want you to talk about first, principal energy levels and sublevels. So, a principal energy level is basically the row on the periodic table with a few exceptions. Is designated by the principal quantum number. So, the first energy level has a quantum number of 1, second energy level has a quantum number of 2, da 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 da. Energy levels are further divided into sublevels. So each principal energy level has as many sublevels as the quantum number n. So first energy level has 1 sublevel because the quantum number would be 1. Second energy level has 2, third energy has 3, fourth energy level has 4. The fifth does technically have 5 and the sixth does have 7, but for the most part we can kind of pretend that we just stop at 4. So 5, 6, and 7 would all have 4 sublevels as well. So again, those sublevels are the S, P, D, and F sublevels. Let's talk about them a little bit later. So each sublevel has 1 or more orbitals, each of which can hold 2 electrons. And again, if they are in the same orbital, they need to be spinning in opposite directions. Good old Pauli exclusion principle. So the S sublevel has 1 orbital. It can hold 2 electrons. P sublevel has 3 orbitals and can hold 6. So 3 times 2 is 6. D has 5 sublevels, so 5 times 2 is 10. And F has 7 orbitals, so it can hold 14. You might be asking you, well, what do these sublevels look like? So S sublevels are shaped like spheres. So when we did that where you dropped the marble lab, I forget exactly what that was called, you had spherical orbitals. P orbitals are shaped like balloons. In my opinion, they look like balloons held together at the end where you tie them. But the book uses the term dumbbells. So P orbitals, the P sublevel has 3 orbitals, P1, P2, and P3, or Px, y, and z. So the combination of these 3 is like a 3-dimensional image that you can look in the book on page 144 and 145 to kind of get an idea what it looks like. D orbitals look somewhat like a 4-leaf clover until the last one, and it looks kind of weird. Again, look on page 144, 145. If you know that S orbitals are spheres and P orbitals are dumbbells, that's really what I want you to know. So the rules for filling them. I've got 3. Off-bow principle. Off-bow means, I think, filling from beneath. Or building up. Off-bow means building up. I had to look that up. That's what the page-turning sound was, if you could hear that. So electrons are added one at a time to the lowest energy orbital available until all the electrons of an atom have been accounted for. So, in layman's terms, you start at 1s and you work your way out. Remember that from the other video that I stole. If you start with 1s and just work your way out, you'll be fine. Those are the orbitals. Pauli exclusion principle. I mentioned this a little bit earlier, but an orbital can hold a maximum of 2 electrons, and for those 2 electrons to be in the same orbital, they must spin in opposite directions. And Hund's rule says that electrons occupy equal energy orbitals so that a maximum number of unpaired electrons result. Again, we talked about this earlier. If they don't have to share the same seat, they don't. They don't have to share the same seat, they don't. So again, with a 2p sublevel, you can have 3 orbitals in there. So there's 3 little boxes, and each one would have 1 electron by itself before any of them would double up. Electrons are negative. They don't like other negative things, so they try and get away from them. Exceptions, ground state and excited state. Ground state is where you'd expect to find it, given the rules. So lithium would be 1s with 2 electrons and 2s with 1 electron. Excited state is when an electron absorbs energy and jumps to a higher than expected orbital. So if this 2s 1 electron suddenly jumped into the 2p1 orbital, it'd be higher than we'd expect it, and it'd then be an excited state. Usually they don't stay in an excited state for long, they fall back down, and that is the end. If you have any questions, talk to me in class.